the streaming, and then what we'll do is I'll show you an overview for the summer at least. Yes. Sure. Sure.
Because this he has a lot of issues I don't want to repeat it. Yet he's so good. It's like knowing a new person that I don't know what is going to happen.
Yeah, but I don't want to forget.
That's the thing. I don't want to forget. If I wait to fall, everything what I have learned is like, wait, I have to continue.
Okay. So the 141. So those of you who take 141 as your next class, this is the Math AS for it. I'll show you the resources, but they may work them in a different order. I kind of go out of order. I start with chapter 8 and 9, which is probability, because I found that that's a little easier for students to get started with. And then I go to the statistics, which are 10, 11, and 12. And then, so I skip around a bit. A lot of teachers do start with like chapter 1. I don't know why, but I'll just pull it up. Each of the chapters, this is the same pretty much which each one of them has. There's a textbook, so this is chapter 1 textbook. I'll show you what that's like. And like I said, it's more of a formalized textbook that you would read and you see examples. And then at the very end of this chapter, after showing you examples and how to do things, it has what's called practice problems.
But there's videos in it that talk the things?
Not in the book, but where the videos are is here, Little Crow's geometry videos. So I've made up some videos. Last summer, that was my project. I made up videos, and there's a link here. Takes you into my YouTube page, which if you've subscribed, it's the same YouTube page, and I've got them kind of separated by chapter. I didn't make a lot, but there's, what's this? There's, yeah, you'll pick up my other stuff.
So is that what 141 is geometry?
No, it's that's one chapter.
Oh.
What 141 is, it's a survey of math topics. So you'll have geometry, you'll have measurement, you'll have, there'll be a section on linear equations, which we're doing here. So this is,
So it's harder than...
I wouldn't say that it's harder. In fact, a lot of people find it's different. It's math for non-technical math majors. This one's really preparing you to go do some more math, like if you're going on to more algebra. 141 is not an algebra class. It's a survey of how to do math in the real world. So again, people take it differently, but there's one section here on geometry. That's it. And then and the way it basically works is you kind of go over the reading, maybe look at some of the videos. There's a reading quiz which has 10 questions that are covered sort of in the reading. And so you kind of work through these. And then you start in, finding perimeter or whatever. And then what you'll do is so I've got some PowerPoints in mind for the class presentations. There's the geometry homework, which are more questions. And again, these are all Math AS type stuff. And you work through it. This one has 44 questions, but this is basically what we use. Okay, so you'll work through the questions. How she sets up her class, again, each instructor has the freedom to set them up, but she, I believe, uses the same system. Some people just use the book and the practice problems. Some people use these where you're actually solving and putting in your answers. And then,
is the textbook required for in the fall?
well, it's available in Math.AS as a PDF. You can also buy it as a printed textbook from the bookstore. It's about $20.25 because it's really just we use a low cost printer, but it's also all available in Math.AS. So you don't have to buy it. It's up to you.
Okay.
So, and I usually tell students to give it a try. If the first chapter, if you're finding that you need to print it out a lot, go buy it because it's
basically like this. So. Yeah, because it's printed, no?
It's printed, but that's more of a workbook where it's actually got stuff for your work. This really is a reading type textbook. So it's a switch. It's a college level math class where we're trying to help you learn how to learn from a book. Let's see, let's go back. And then there's a test, but the test comes from the homework problems, so they're all sort of interrelated. And you go through it, and that's about it. There's also some additional videos down here, area of a triangle, that are basically, so it's structured a little differently. It's more thematic. So if you're doing a problem, you have to kind of say, okay, what kind of problem is this? Oh, that's a Pythagorean theorem problem. So then you know to go check out this video here. Or maybe it's a square root problem. So then you check out some videos we have here.
I have a question. Is there a tutoring class too?
Not in the summer. There's no 108 tutoring classes in the summer. There are in the fall.
Okay.
But the summer we just don't have enough.
So neither in the lab?
There's tutoring in the Math Tutor Center, but there's not a tutoring class. There will be, Martha's here, she does have some hours for what they call the math gym. I think it's maybe 6 hours a week. But she's
For the summer? No.
for the summer.
For the summer.
Yeah. But there is no regular tutored class.
But she will be, I need to call her to talk to her first. She's gonna be, what hours? She will
Sure,
be?
yeah, her hours will be set up of what she's going to do
It's
with
a
each
different,
one.
not different name of class, or would she just?
There's no class.
She's
Yes.
just gonna help.
She has an open lab,
Okay.
yeah. And she'll be in 473 for those hours.
In the same class, in the same.
Yeah, but it's
Okay.
it's not something that you sign up for like the
Okay.
Math 108.
Okay.
Okay, so it's it's different, but it's just to get you back to the list of topics. You'll do probability, you'll do statistics, linear functions, Venn diagrams and sets. There's financial math on savings plans and loans and percentages. So it's kind of a mix of a lot of different topics, but it's a good class. But yeah, if you need more, we do have during the school year a little bit more support as far as having. We do have Math 108, which you can sign up for 141 as well. Okay. But as you see, when we do ours here, if we're to about 10. Our book, our workbook is really a workbook, so it's got a lot of problems that we go through, whereas in 141, it is really a textbook that explains, and so it's a little different.
This is not this.
Right, it's a different book. Okay. Let's take this down. So any other questions? Or you just want to go back home tonight? Just call it off. Again, I apologize. That's the thing with summer schedules. We have to make them way back at the beginning of this semester. And oftentimes, and actually I asked them back in December, so people have to kind of commit, but we, as summer comes, sometimes other things happen. And then we're not able to teach during the summer. So, okay. Lesson 10. So we've gotten about halfway through it. Can anyone give me what a linear equation looks like? What is a linear equation?
Y, like y equals mx plus b.
Very good. So y, so this is our main format. And remember these two values that we're going to come up with, the number in front of the x, the number by itself. What is it that the number m, what does it give us? When we know that number, the slope. Or the steepness of the line. Is that right? The angle that the line makes, although we usually don't measure it with an angle. So that's, so that's the steepness. What does the value of b give us?
Vertical.
Very good. Vertical intercept. Which is a point 0, comma b. The y-intercept, we also call it, and we also could call it the starting point. Oftentimes in a word problem, this is where we start. It's the fee we pay or something. Good. And then x and y are variables that vary. I plug in an x, I multiply it times the slope, I add b, and then I got y. I put in a different x, I multiply it times the slope, I add b, and then I get y. So, an example of this might be y equals, say, 3/5 x plus 2. So let's just kind of talk how we might go about graphing this. So do a y-axis here. An x-axis here. And so where would I plot my first point? At 2. And where is the 2 that I plotted on?
Y.
Okay, so there's a 2 here, but that's not the one I want. It's the 2 up here. Good. So I put a point here. Good. And from that point, where do I go?
Up 3 over 5.
Good. Up 3, because that's the top is a change in y, the bottom's a change in x. So I'd go up 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. And this is not going to be really accurate, but that's where I'd get a second point. I could have also gone down 3, 1, 2, 3, and then back 5. So that's a 1, 2, 3, 4, 5. Okay, so this was a negative 3, negative 5, or I go up 3 over 5. And we see all of them are pretty much on a line. Well, not quite, but that's what happens when you don't have a nice grid to work with. But we would be able to draw the line and they would all be on the line. Okay, so the next one we'll work with, we'll actually use a grid. I think I went down too far there, so let's see. Come back and
This is slope, and then what is this? The steepness?
steepness. Yeah, how steep it is. Down a little too far. Here, back about 5. And I'll just freehand it so we get a line that's sort of going like that. Straight line. And now you know that's not accurate. So okay. We'll do a few others today. What today we're going to look at, and then we did some examples of where we had a point and a slope, and you could do it from some other place. We also looked at how to find the equation of a line. If I give you the point, if I give you 2 points, if I give you a point and a slope, or if I give you the point and the y-intercept. So we looked at all of that last Wednesday. And hopefully I got the video posted. I don't know if we were able to live stream or not, but I think all that's taken care of. I'll look at it again tonight when I get this posted up. So tonight, what we're going to take a look at is what happens in 2 special cases. One case is when we have parallel lines, the other is when we have a perpendicular line. So for this, I'm going to help myself by going to, let's see, I'm going to go to a grid. Isn't that better? So this will make sure we're a little bit more accurate. I'm going to, let's go ahead and stick with red. So I'm going to put in a y-axis. So there's my y-axis, and here will be my x-axis. And we're going to talk about parallel lines. So I'll first go ahead and draw a line. Let's go to sky blue. Let's see. Now let me eyeball it. Let me put another vertical line, or not a vertical line, another line that's here. So let's look about parallel. Think fairly close.
Yeah.
Okay. So what, when 2 lines are parallel, what do they have in common?
You don't cross.
They don't cross, and their slope is about the same. Well, let's see, maybe a little bit more than about. So what's the slope of this point? So I found, or this line, I see a nice point here. Oops, I don't want that. I have to change my tools. Undo that one. This one. So I get a point here. And if I go, oh, there's another nice point. So what's our slope here? 1, 2, 3. So go up 3. And then we run 2. Rise over run. 2 over 3. All right, so we have this one has a slope of 2 over 3. I'll do that. 2 over 3. Let's see this other line that's below it that's supposed to be parallel. Let's see. There's sort of a point there. There's another one about there. And that's also a rise of 3. Oops, I did that backwards, didn't I? Rise of 3, run of 2. I told you this was the hardest part for me. It's simple. One goes on top, one goes on the bottom, but it's also simple to reverse it. Everyone else catch that the slope was wrong? right? You were thinking of it, saying, it doesn't seem right, right? Rise of 3, run of 2. So the slope should be 3 over 2. I think that's why I wrote the 3 first, because part of my brain was saying rise of 3, run of 2. Okay, so that's that slope. This one has a slope of rise of 3, run of 2. Does that kind of make sense? What if they weren't the same slope? What would eventually have to happen? They would have to cross because one would rise faster than the other, one would rise slower than the other, but eventually there would be a place where they'd have to cross. The only way they will never cross is if they rise and run in unison. I think to this, I don't know, I was a teenager. I had a younger brother. He was 7 years younger than me, and I remember we were best friends. And he told me one day, he goes, I can't wait until we're the same age. I said, okay, bro, I love you too, but the only way we're going to become the same age, you're going to have to bump me off because that's you'll catch up to me. As you get older, I'm getting older. I know I don't like it either, but this is parallel lines. Each year, he got a year older. He thought he'd catch up to me. That was great. That's what's nice about being, young. You don't have all this experience. You think, oh, older brother, he's going to always be there. He's always going to be 15 years old, whatever. And I'll catch up to him. We'll all be 15 years old together for the rest of forever and ever. But no, parallel lines, slopes, as one gets older, the other gets older. Okay, so the slopes are the same. They have to be. If they aren't, it won't be parallel, right? Because one line will eventually catch up to the other line. So that kind of makes intuitive sense. But what I wanted to do, what I want to start off here, is we can say that, yeah, with parallel lines, slopes are equal, slopes are the same. But what about the y-intercept? Are the y-intercepts the same? No. In fact, they can't be the same. If they were the same, it would actually be the same line, wouldn't it? They can't really, if you're parallel, you have to have two different lines. So they have to have two different starting places. And this is going to become important because the questions about parallel lines, they give you a starting line. And one of the biggest mistakes is people want to use the y-intercept from that line. But if I've got a line and I'm parallel, if I got a second line that's parallel to it, they will have nothing in common as far as the y-intercept. The slopes will be the same, but the y-intercepts are guaranteed to be different. Because if they weren't, we'd have the same line. Okay? Sear that picture into your mind. Okay. So this is a concept. So let me, so this is kind of what it looks like. Slopes are going to be the same forever and ever, amen. Y-intercepts will not be the same. There is no relationship because one y-intercept, you have no idea what the other y-intercept is going to be. In fact, there's all sorts of parallel lines on here that would have all sorts of different y-intercepts. As long as it has the same slope, it will be parallel to that line. Okay. Let's see. Parallel lines. So let's get a new page. Let's clear this off and I'll show you an example of a question. We'll leave it at that. Find the equation on the line. Okay, so we've got a line that's parallel to the one that's given, y equals 3x plus 2, and it goes through this other point, negative 4, 5. How do we go about finding the equation of this line?
Plug in your x and y
To where?
to the equation.
This line, our line is parallel to this one. This point is on the line that's unknown at this point. It's not necessarily on this line.
Plug it into y equals mx plus b.
Okay, so yeah, so we got a new line, y equals mx plus b. Good. But if we just plug in the point and we don't know m and b, then we're kind of stuck. But what do we know? What is this thing being?
You said before the 2 is the slope,
Mm-hmm.
so that's B, right? No, that's M, I'm sorry.
Good.
I wasn't here last class.
Okay.
So,
Catching up. I
okay,
think. Okay.
so 2 is the M, and then 3 is,
3 is the M and 2 is the B.
Except remember, from parallel lines, y-intercepts don't carry to the next line. You have two parallel lines. The slopes are going to be the same, but the y-intercepts will be different. Okay. So what we know, so you're exactly right, we're using y equals mx plus b. We know that the m will be 3. So let's go with this. So we'll have y equals 3x, but we're going to have some different value for b, some different y-intercept.
Is the Y is gonna become 5
Good, and then we take our point.
and the X is gonna become -4.
Exactly, good. And look at that, we can solve for b. 3 times -4 plus b. Now we do the math, we do the algebra. 3 times 4 is 12, right? And it's -12. It's positive times a negative plus b. How do we solve for b?
Positive 12.
Add 12, good. Positive 12 to both sides.
Is 17.
Very good.
So it's B 17.
B is 17. And so now we've got the slope and the y-intercept, so we can write the equation of the line y equals 3x plus 17. And that's the answer to this question. There's at least one of these type of questions very similar to this. They give you equation of a line. We have a line that's parallel to it that goes through some other point. So what we do is we take the equation of the other line, just we take the slope of that line. That's all we take from it. So I like to cross out the y-intercept because so many people want to put in 2 for the y-intercept. And then nothing will work out, okay, because it's not the right line. We use the point, we plug in the x and the y values, find the y-intercept, the b value, and then we've got our equation. That's all there is to it. So this is like what we were doing last Wednesday when we had the slope. I gave you a slope and I gave you a point. This time I'm just giving you the slope, but I give it to you in a roundabout way. I give you an equation and I tell you we're parallel to this line, so that's how we get our slope.
okay, I wasn't here last week, so why did you X out the 2? Why did
Because we're not going to use the 2, right? It's
I
the
don't know. That's what I'm saying. I don't know why you did it.
because when we looked at parallel lines, just the slide before this, they have the same slope, but they will have different y-intercepts.
Oh, so that 2 was actually representing Y?
It's a y-intercept, yes.
Oh, okay.
Right? It's a vertical intercept for
Okay.
this line, for the line up here. But it's not going to have anything to do with our new line. Okay, so remember, when we talk parallel lines, there's 2 lines. That's one thing is people, I think, when you're working through this, you're thinking of one line, but there's 2 lines. One we have the equation for, we have everything we need on it. The other we don't have the equation. So what we get is we take the slope, just the slope, of the old line, Okay, so what we know is m equals 3. And then we forget about that line. That line has nothing else to give us. We now know we've got a line that has a slope of 3 and it goes through this point. Okay. So we set up our equation, y equals 3x plus b, because that's what we know, the slope is the slope, m is m. And then we plug in the y-coordinate and plug in the x-coordinate, and that's what allows us to find the missing piece, the vertical intercept, the b. Okay. And then now we've got this equation, and again, now watch what happens when we plug in -4 and 5 to this equation. I get 5 here equals 3 times -4 plus 17. 5 equals -12 plus 17. -12 plus 17 is 5. 5 equals 5. It's a point that satisfies the equation. So see how this kind of takes us in circles. We were doing problems like this previously on the check. So this is more just a check.
So when you solve the problem, that's the answer, 5.
What I've got circled here, y equals 3x plus 17. That's the equation of the line.
Yeah, because in the problem, I mean, keep on trying it. That's why they want the equation.
They want the equation of the line. Y equals mx plus b. Just so for this, for 10, and actually as we get into 11, our answers always look like y equals something times x plus something. We're filling in those two numbers. Filling in those two blanks with numbers. I use blanks instead of m and b because, you know, we're just looking for those numbers. And once we find those two numbers and put them in their place, in this case, what we found was the thing in front of the x was 3. The thing without the x is 17. Once we just kind of put them in their place, that's all we do. We got the answer. So we had to kind of do this sort of work to get there, but this is the answer in these two, in chapter 10 and most in 11. 11 gets a little different, but we're just looking for the equation of the line. We could take that and graph it if we needed to.
So the equation of the line.
This is the equation of the line. And we can plug in different values for x and figure out what other values for y are. We get all the points along that line. Okay. And we know these two are parallel. Why? Because they have the same slope. Notice they do have different y-intercepts. And that's what's going to happen with parallel lines. So far, so good? Okay. So what we're going to do is we're going to dive into the next type of line, which are perpendicular lines. And then we're going to see that it's really the same thing, but this gets a little bit...
Is that where they cross? Or?
Well, what's perpendicular? Two things are perpendicular. What do they do?
On top of each other?
What does it mean to be perpendicular? We have 4 examples, one in each of the, well, actually maybe more, but in the corners, those walls meet at a perpendicular angle. Perpendicular is
One's up and one's out, but
90, crossing at 90 degrees. So perpendicular is when two lines cross at 90 degrees. I like the little X. And actually, if you could do this right now, go ahead and make the X sign in front of you. Okay. Which one, wave the hand that's got positive slope for you. Good. The one that's going up, right? Well, am I right? Wait. Left to right. Oh, I was wrong. See, I thought it's easy. This is the positive slope one for me. From my perspective, I better. So if I go the way you guys are going, yeah, that's the positive slope. That's the uphill slope. Which one has negative slope? The other one. If we have perpendicular lines, one has a positive slope. What are you guaranteed the other one will have? negative slope. The slopes will always be opposite of each other. One will be positive, one will be negative. Guaranteed because of this. Okay? And it's a 90 degrees. It's not like a scissor thing. It's exactly 90 degrees. Okay? But we're going to look at one other characteristic that comes out of here, and I'm going to see if I can illustrate it with another graph. So we will go back to not that one. Go to the grid. Then I'll draw in a X and Y axis. So Y-axis. Now let me draw in one line, and we'll see if we can draw one that's going to be perpendicular. So I'll just let's go here. So this has a slope. It looks like a rise of 1, a run of 2, a rise of 1, a run of 2, a rise of 1, a run of 2. Do you agree with that? Okay. So I'm going to get a line that's perpendicular to it. So let's choose a slightly different color. I'm going to choose a line that comes from here. It's got to go negatively. So what if I do it this way? Okay. Now eyeballing, does that look about like a 90 degrees angle? Doesn't, huh? Anyone got a protractor on them?
Needs to come in more, it's a little bigger.
Should be.
Close, but
Okay, I'll give you that. That's the problem with this face, being able to measure it. And also we're coming through a computer through this, so we might have some distortion. But let me emphasize this, because the way I've created it, it should be 90 degrees.
in the top, up a little bit.
Let's see.
Yeah.
Come from here.
Oh, yeah. I'm sorry.
It's even worse.
I'm sorry. Oh,
Right there.
Up there,
To the left.
Because you're trying to create
90 degrees.
the opposite of
Close
what.
enough.
Okay, good. So if that appears to be about 90 degrees, again, we would need a measuring device, a protractor to actually measure it. But the idea is what it actually ends up happening. If we use graph paper and actually make it with 90 degrees, what we will see is that this one will have a slope, a rise of 1, a run of 2. So that's a slope of 1/2. And watch this one. It's got a rise of -2, a run of 1, giving a slope of -2 over 1. So do you see the relationship between the slopes? They're flipped. And that's really what you need to remember with perpendicular lines. When you're told that you have perpendicular lines, write that word down. perpendicular, that this is going to be 90-degree lines. They meet in a 90-degree angle. That if you know one slope, then the other slope is going to be, so if one's positive, the other's going to be negative, and then you're going to get the reciprocal of the slope. Okay. So what the ways this work is just like with parallel, they give us one line, they give us one slope. We have to work with the slope that's the opposite sign and the reciprocal. Okay, so just an example down here, if I have a slope of -3/5, what is the slope that is, I'm going to use this math symbol for perpendicular. That symbol means perpendicular. So what would be the slope that's perpendicular to a line that has a slope of -3/5?
5/3.
Got it. Positive 5/3. Exactly. So it's going to be opposite sign, and it's going to be flipped. That's all you need to know for perpendicular lines. But again, do perpendicular lines have the same y-intercept? In this case, they don't. It could be possible if they intersect on the y-axis. It's possible that they could have the same y-intercept, but not necessarily required and not very likely. Okay, so notice these lines have different y-intercepts. So when they tell you that two lines are perpendicular, there is one thing they are telling you, that there is a relationship of their slopes. One slope is this, the other is the negative reciprocal of whatever the other was. That's all they're telling you. Okay, and again, you're guaranteed there will be at least one question on the test, on the final exam, that talks about perpendicular. So we'll work through a problem. It's really the same thing we did with the parallel, except when we get to the point of the slope, they're not equal slopes. We take the opposite reciprocal, and then we plug in the point and go from there. Okay? Questions? Does that seem reasonable? Because when they're perpendicular, it's this quality that the rise and run change places. That's how you get that 90 degrees. It's kind of like thinking of anyone in the building trades or done some building. You know, yeah, so it's kind of like a stairs would fit together. Yeah, at a perfect angle. So when you're building, it's just it's this thing of geometry. Okay, so we'll let's take a picture of this one. So instead of making one up, I'm going to pull up the MAT-AS workbook, and let's take a look of where we're at. Where did it go? Shoot. See if this works. Oh, I know it's the, let's see. I'll pull this thing back. Let's close this thing. Now they're going to make me remember my password, huh? That's right, yeah, good. Okay. I think after this, we'll take a look, but I think we might have, open up, we might have a little bit on vertical and horizontal lines, and then we'll be basically ready for lesson 10. So we did this stuff last Wednesday. Let's see. Some of this stuff, maybe we'll look at some examples. Let's see.
This is what we've been doing is not Unit 11.
No, this is Unit 10. The last part of Unit 10. Okay, here we go. Oh, perpendicular lines, yes. Okay, here we go. Okay, actually, okay. So we did a couple of these, we did these, horizontal, okay. Let's start with this one, and then the next one will be parallel and perpendicular. Okay. So we want the equation of a horizontal line. Passes through here. Horizontal line. What do we know about a horizontal line? Good. That's it, right? This is the horizontal, and it helps to get track between vertical and horizontal. So what kind of a slope does a horizontal line have?
0.
Good. Has a slope of 0. So what we know is we've got a line that is y equals 0x plus some value of b. Okay. How do we find out what b is? Well, we know the slope, and we know a point, so what do we do with that point, 511? 5 in, the x in for x, and the y in for y. So then we get 11 equals 0 times 5, we're plugging in for x, plus b. Well, what's 0 times 5? What? 0. Good. I thought I heard 2. And what's 0 plus b? B. When you add 0 to something, nothing changes, right? So what we know is 11 equals b. So our equation of the line is y equals 0x plus 11. But what is 0 times x? What's 0 times 5?
0.
What's 0 times 10?
0.
What's 0 times 23 million?
0.
What's 0 times x?
0.
0 times anything is 0. 0 times 0 is also 0, but yes. So we can, basically, we don't have to write this. You might sometimes want to leave it there, but it's gone. This is our equation. Horizontal lines are just y equals a number. So it's a horizontal line at y equals 11. So you go up to y11 and you'd have just a horizontal line there. That's it. X can basically be anything because as soon as you plug in x, it gets multiplied by 0 and it's not there anymore. 0 is a mathematical way of ignoring things.
Is it always going to be like your y value? I feel like it's pretty much always going to be that, right?
Yeah, if you've got a point and you've got a horizontal line, it's the y value that tells you the equation. So yeah, once you do these, and that's why I do this, I want you to see the pattern in the future. I would hope you'd say, oh, whatever the y value is, it's y equals that. So for a vertical line, what are we looking at?
X.
X. So whatever x is equal, that is it. So when they're asking for either a horizontal or a vertical equation of those lines, those are very easy, but at the same time, they're very difficult because you have to remember what you just said. That a horizontal, it's only the y that's important. We ignore the x. It's y equals the y value. When we've got a vertical line, It's only the x that's important. It's x equals that number.
Yeah.
It's the opposite. Okay, questions or thoughts? Or does it kind of make sense? But you see how all of this it's simple, but it's also easy to reverse in your mind. All this stuff. And that's how math is. And it's just getting through a maze. Left, right, right, left, right, left. In the right order. But one false step could put you in a completely wrong direction. So that's the difficulty with math. And so part of this is as you go through spotting, if you can spot where you got off a step and go back to that, say, and let me go the other way, oftentimes you're going to be just fine. You see me, I do it myself. With slope, I'm going, you just have to find the place that you get off. Okay. Oops, let's get a clean page. Okay. You have the equation line passing through these and these. Okay, oh, we just did this. Okay, so we want to go down. Just scroll on down. Parallel and perpendicular lines. Okay, so here's an example. They allow you to draw them if you want, but this is a sample. We'll do the parallel line again to emphasize it, and then we'll do the perpendicular to, because it's typically sometimes a little bit more difficult. It's got a little more extra steps. So give the equation of the line passing through this point, 8,3, that is parallel to this line. Where do we start? What do we know? We know the points. So our line goes through these points. What else do we know about our line?
The slope.
We know its slope because it's parallel to this. So what's the slope of our line? Exactly. So what we know, and then we could forget about that line. That's all that line gives us, is that our slope, our m value, is -2. And we've got a point. That's all there is to it. So now, and again, I'll just cross this whole thing out. We're done with it. We've got y equals -2x plus b. This point gives us a x value and a y value. So we can plug those in. So we get 3 on this side equals -2 times 8 plus b. Now it's just time, everything's ready for us. We just do the math. We multiply, and then we either add or subtract. Looks like we're going to add. So we get 3, 2 times 8 is 16, which is negative, because a negative times a positive. How do we get b by itself? Positive 16 to both sides. That's gone. 3 plus 16, we end up with b equals 19. And there's our equation. Y equals -2. You could rewrite the b. So we got y equals -2x plus 19. So that's really all our task is in pretty much in lesson 10 is to find the slope and find the vertical intercept. Put them together in an equation, do a little dance, and we're done. Happy dance, hopefully, instead of the frustration dance. Okay. And we've got the point, because we know when we plug in the point on the line, it's going to satisfy that equation, so it helps us find those missing pieces. And this is a technique used in math. If you need enough information to narrow it down to one unknown, then you can solve for it. Okay. Does that make sense?
Yeah, because it's confusing when you put it there.
Yeah.
I got stuck in this.
Okay.
So many things.
Yes. And again, ordering is very important. It's so easy to put them in the wrong place, putting the y in for x and the x in for y, and then you get a mess. But it's just switch it and you'll be fine. You know, but it's,
You do it in the lines in the.
oh, up here if you wanted to graph. I mean, yeah, you could. So y equals -2 plus, but see, this is going to be hard to graph because 19 is like going to be way up here. But that's why they give it to you.
That's why it took me a long time
Yeah.
because I tried to do it and it's, I need to think minus, is b, which is 19.
Right. So this is 10. 19 will be like up here. So you put a point. Slope is -2. So you go down 2 and over 1, down 2. And so it's not going to be a really accurate, pretty graph, but you'd see this one. This slope I crossed out, but it's y equals -2x plus 3. That one you could, here's 3, so there's that one. It's down 2 over 1, down 2 over 1. And again, if you've graphed it correctly, you sort of get parallel lines, but it's not a very, they didn't give us enough graph paper to work with.
Is that going to be in this?
No.
With the graph?
The test is multiple choice. You just have to choose the right
Also,
equation.
the graph, I should not.
Yeah, graphs are, I mean, they're there to help you. Yeah, but don't, we're not going to have you draw any
Sometimes
graphs.
when the graph isn't there, you think you just wish it.
Yeah.
Stressing myself when graphed.
On the media lessons, go ahead and watch them, and they'll probably do it for you if you want. Then you can see it. I think it's good to see the visual, but yeah, the process of drawing the graph can be a little intimidating, especially on this one. If they didn't give us a very good graph paper.
Even in the video, it doesn't show
it.
clear, and I want
Okay.
somebody to help me to put it for me, so I'm like to see it first.
Yeah, yeah. So it's just, and that's why I said, focus on getting the equations, and you'll see. And that's what the test will be on, just finding the equations. Okay. So far, so good? Okay. Perpendicular lines. Let's see those. There we go. Put that out. So we've talked a little bit about perpendicular lines. What's going on here? Just want to be able to. Okay, so they talk about the slope being the negative reciprocal, the reverse reciprocal. Let me make it a little bit bigger. Okay, so now we've got the same information, but instead of being parallel, we've got reciprocal, or we've got perpendicular. Okay, so they're using actually the same point, this same line, y equals -2 plus 3, but this time we're told the two lines are perpendicular to each other. Okay, so that means they're going to cross at 90 degrees. Okay, so again, these problems, they're just telling us about the slope. So if the slope of the line that we're perpendicular to is -2, I'll do that. And think of it as a slope, as a fraction, -2 over 1. What's the slope of a perpendicular line to this?
1 over 2.
1 over 2, positive 1 over 2. So 1/2. That's the slope we're going to use. Okay. So with these perpendicular lines, all we do is we have one extra step.
What does that mean?
Perpendicular. This?
Yeah.
Yeah, that's my sign for perpendicular.
That's your sign for what? Perpendicular.
Perpendicular.
Oh.
Go like this. It's sort of an upside down T, and that means perpendicular. This is what they used in high school, so it might have gone out of fashion. This was late 70s sort of stuff. Maybe they got some new. It does, yeah. For the sign, it doesn't cross. It's more like an upside down capital T.
Well, because you just want the 90 degree angle.
Yeah, we're just kind of.
One or the other.
Yeah, we're just focusing that it meets at 90 degrees. Okay, it's my shorthand. But again, this was also one of the things when I went back to graduate school that got me almost to drop out of graduate school in the first week, is all the symbols they use when they teach higher level math. If you translate it, it's not so bad, but when you start seeing signs that are like, does anyone know what that means? It's the math symbol for all. It simply means for all. So instead of writing for all such and such, they just write this symbol. And there's a lot of others. Again, we won't do that to you, but I mean, I was seeing this professor who liked to use a lot of shorthand, and I couldn't read the shorthand. Fortunately, I had a friend in class who showed me the shorthand and says, it's not that big a deal, just translate, write what he writes, then you can keep up with the class, and then after class, go translate it, and it'll all make sense. He was right. Kept me going. Okay. So yeah, that's just sort of my symbol for perpendicular. You could come up with your own. You could do something different if you want. But yeah, if we use a cross, then it looks like a plus sign, and so that's why they do that. Okay. So what we want to do, find the equation of the line. So y equals, what's our slope? Positive 1/2. Okay, that's the slope we're going to use for our line. How are we going to be able to find the vertical intercept? We're going to take the point we were given, which has an x value and a y value. We're going to plug those in for x and y. So I'll write it over here because it's so far away. Make sure I plug them in the right place. I'm not sure I did that last time. So the 8 goes in for x, the 3 goes in for y. Now I got this weird feeling like maybe the last one I did backwards. I'm not sure. Okay. So now we've got to do a little math with fractions, but what's 8 times 1/2? 4. You could think of it also as 8 divided by 2. So that's 4. It's not that bad when you think about it. Or you can plug it in your calculator if you want. But yeah, it's really just, it's not that bad.
It's 8 over 1 and then...
Yes, good. Think of it as 8 over 1, 8 times 1, 2 times 1, so it's 8 over 2, which simplifies to 4. And so then how do we find b? Get rid of the 4, so we subtract it. Minus 4 from both sides. And what we find out, it cancels on this side, negative 1 on that side, so negative 1 is equal to b, and we're done. It's almost. We just need to write the equation, or on the test, we need to choose the right equation, right? It's going to be multiple choice. You just have to be able to pick out the right equation.
The right equation is going to be in there. Oh,
Yeah. What do I? What's the slope?
It's 1 over 2.
1 over 2.
X plus minus 1.
Plus minus 1, or just minus 1. However you want. Yeah. So that's all it was. Is the first step was to find the slope. We had half the answer at the very beginning. Just by flipping it and making it positive, we had half our answer. We plug in the x and y, that got us the y-intercept. We have all of our answer. So again, we're just looking to find 2 numbers in all of these questions. So simple, yet so complicated at the same time. So many places to go to the left when you were supposed to go to the right, or vice versa. And I tell you what, I've taken all the possible pathways there are until I got really confused, and then I stopped. But then you come back and you just say, okay, there was probably one step I went the wrong way. And if you can locate that, switch it, and then go forward, you'll be fine. Does the process itself seem reasonable? Sure, if you say so, little bro. Okay. Oh, shoot. Sorry, folks. The live stream you've just been watching a picture of downtown Phoenix. It switched to the wrong video. So this is, they've been hearing the right thing, they've just been seeing these skyscrapers. Because I use that for my backdrop for some of the pictures I do. I have a green screen at home. You ever watched, I haven't do any of those videos? Wonder how, it's kind of cool, all the stuff you can do. It's just making my work fun, you know? So that's why I put some different backgrounds in. But I unfortunately hit the wrong thing, so the folks on the live stream, so when you go to watch the video, you'll see, yeah, instead of perpendicular line stuff, you'll just see some skyscrapers. So if you have questions, remember, just send me an email and ask for me to do a video on this problem or that problem. I'd be happy to do it. Occasionally I get them for my 141s and stuff, and sometimes I've already done the video, and then I'll put you to the video I've done. But this one, yeah, if you've got a question, a lot of times that's the easiest way. Just send it. I'm not sure how to get approach to this. I'm not even sure how to start. Could you make me a video? Yes, I'd love to. And then if you see the video and it says that still didn't help me, could you, again, we could go back and forth a few times. I tutored a student while I was in Kazakhstan. She was a high school student here, and we didn't have all this technology, but she would hold up a page to her webcam. I'd write down the problem, and then I'd hold up my page to my webcam. And we were able to tutor halfway around the world with webcams. It's just, humans connect with humans all over the place. So just let me know what you need, and we'll get it done. Okay.
I do have a question.
Yes.
When you were doing the one, the example one before,
Mhm.
you don't have to go back to it. Did you, on the -2x part, is that like this one? Do you always put 1 underneath the
Yeah, anytime you have a
X-
whole
the
number slope,
number with x?
Yeah.
You always just use 1.
well, if it's a whole number, you use 1. If it's a fraction, just use the fraction. Because what when we got the number in front of the x, it's a slope. It's just easier to think of it as rise over run, the change in x over the change in y.
But I just wanted to make
Yeah.
sure that the number that you are putting down below it is always 1.
Yes.
And then you're going to flip it. So
Right.
it's always going to be then the -2 over 1.
Yes.
That's what the
Right.
equation says.
Yeah, so like here, they give us these, so a slope of 5,
It's going to have 1.
we think of that as 5 over 1.
Okay.
So when we get a slope that's perpendicular to it, it's going to be negative because this is positive, and then it's going to be 1 over 5.
Okay.
And when there's like 2/3, this is going to be negative
3 over
3
2.
over 2. Negative 8, put a 1 over it, flip it, 1 over 8.
-1 though. No, it's positive because
yeah,
that's
good.
already negative.
Yeah, it's already
Okay.
negative, so the slope
So
is
it's
going to be
1 over 8.
positive 1 over 8. Negative 4/5, so this is, the other slope's going to be positive, and it's going to be 5 over 4.
Right.
Good. The problem is you'll remember this now, but then you'll start wanting to flip the fraction all the time. But it only gets flipped when we're dealing with perpendicular. Okay, so I did this with my class, I think this afternoon. I was thinking, context is so important. You come dressed for class in a certain way. When you go to the beach, it's perfectly fine to go ahead and wear a bathing suit. But if you wear a bathing suit to class, it's not really appropriate. It wouldn't be the right place to wear a bathing suit. Just like it probably wouldn't be appropriate to dress like we're dressed right now for laying out on the beach, right? People look at us, why are you laying? Yeah, we should at least have some shorts on or something. Maybe a floppy hat or something. But we should look a little different at the beach than we look here. So context is very important. And in math, the same thing. The context is when we're dealing with a perpendicular line, that's when we flip the fraction. When we're dealing with a parallel line, we keep them the same. We don't change it at all because they're the same. And when we're dealing with something else, we don't flip it at all. The only time is when it's perpendicular. But this is where it's kind of fun, isn't it? Just flip the fractional. I think it's kind of fun. But we could carry it too far. Okay, so this only applies when you see this word perpendicular. And it just takes practice. And I guess if you go through these and do the problems and practice it, set it aside, come back the next day, do it again, this is how we learn. And this is how we ingrain it in ourselves. Any of you like to sing? I do.
Only alone.
Yeah, I like the bathtub. The reverb in there is good. No one else really likes it. But when you want to learn a song, right? How do you do the first line, and then you do the first line again, and then maybe you do the first and the second, the first and second, and then you do first, second, and third, first, second, and third. You just kind of keep playing. It's repetition, and if so then you can remember it. At least that's any kind of thing. Do it again and again, and it'll stick in there. And you can kind of trying to take all the time to again see what your context is. Where are we? We're in the perpendicular world. That's where we're going to flip the fraction. Okay. Good. And I think, let's see, and we've done horizontal and vertical at the same time. We've done these, again, parallel, perpendicular, just more examples, you tries. And then applications. Okay, and I'm not going to worry too much about the applications because if you know how to do the technical stuff here, finding the slope and the y-intercept equation of the line, the application problems will fall together. And we can review those later as we get closer to the test and how to do them. But any questions? Okay, questions? Would you like to see this one, you try, since there's no video of it? And since I cut the people off on this live stream, sorry about that, folks.
So the problems we're gonna see it next time?
Yeah, and actually what I like to do is get all the way through and then come back maybe as we start preparing for the final exam to take a look. Well, let's do this. Let's do these two problems together, and then we'll take a look at maybe one or two examples, and we'll see how the word problems, they're doing the same thing. They're giving us either a point and a slope or two different points. Okay? Maybe do one or two examples and then call it a night. Be done by 7 o'clock, and if you have a few questions, you can hang out and we'll talk about it, but that will be fine. Okay. So let's do these, and let's, parallel. What does parallel mean?
Same slope.
Same slope. So we're going to use this slope. We've got a slope of 8. And what point do we go through? Up here. So how do we do this?
1 equals negative 1 over 8x minus 3.
Right. Parallel means the same slope. And then what do we do with the point? I always like to do this step. Some students would like to skip it, but the problem I see is sometimes they put the y in at the wrong place. Sometimes I do. So I like to bring it over here. This is x, this is y. What do we do with the x? Put it there. What do we do with the y? Put it there. And I do it as an extra step. You're not required to, but just judge yourself how you feel when you do them. Watch for your feelings. If it's feeling good, go ahead. If it's not feeling so, if you're not feeling so confident, take a step back until you can feel confident. Yes.
Wouldn't you have to do the slope as negative 1 over 8?
When we're down here, we will. So perpendicular
Oh.
is up. So we're parallel. Okay. And so we just do the math. So 1 equals 8 times 3 is 24. And it's negative plus b. And then what do we do?
Minus 24. Or get rid of 24.
So we add, 24 to both sides, plus 24. So this cancels. We get 25 equals b. And so we get y equals 8x plus 25. Make sense? Okay. The line's perpendicular, so it's almost the same question. We got the same facts, but now that our line is perpendicular, and what does perpendicular look like? Do this. There we go. Muscle memory. You'll remember when you do like this. What's a parallel line? It's like this. So you'll see, same slope. Flip the slope. Okay. It may look crazy, but while you're taking the test, do it. Everyone else will laugh at you, but that's fine. I love when people laugh at me. I laugh at myself all the time. Yeah. It's a great, get some, go ahead. You go ahead and laugh. I'm going to get this problem right because I got the moves, right? I got the moves. Stand up and start doing a dance or something, whatever it takes. Okay, so it's perpendicular. Here's the slope, but our slope is going to be
Negative 1 over 8.
-1/8, because this is like positive 8/1. So our slope is, since it's perpendicular, it's -1/8. Okay, and so we set up the equation. Y equals -1/8x plus b. We're told it's going through the same point, so we've got the point, the x is -3, the y is 1. We plug those in. Y is 1, -1/8 times 3 plus b. We multiply. -3/8, yes, because it's like 3/1. So -3/8 plus b. And this gets a little.
It's a -3.
Oh,
In the
thank you.
parentheses,
Oh.
parentheses is-
Sometimes you just don't listen, and you should listen, little crow. Okay. And so that's going to be a positive, right? Negative times a
Yeah, you
negative.
went back up to the top.
This is
Yeah.
continuation, okay.
Yeah, so it's a, thank you. We'll do that. So it becomes a positive 3/8. And then how do we solve for b? Well, we need to get rid of the 3/8, so you subtract 3/8 from both sides. And this is where it gets a little challenging because we got to now work with fractions. But if you've got 1 minus 3/8, let me come up over here. 1 minus 3/8. What do you need to be able to subtract two fractions? Common denominator. So think of 1 as 1/1. Common denominator, 8. So I multiply the bottom and the top times 8. So I get 8/8 minus 3/8. And then I subtract the tops and the bottom stays the same. 8 minus 3, 5/8. That's our answer. That's what b equals. Okay, right, b would equal 5/8.
I did, on the system where it says 1, yeah, that one minus
3/8.
3/8 is, what do you do? That's how you do it?
So what I did is I went over here, and what is 1? 1/1. Whenever you subtract a fraction, you have to get common denominators. Okay. Or just think of 1, another way to write 1 is 8/8, right? So we're going to take 3/8 away from 8/8. 8 minus 3 is 5. Another way to do this is just simply use your calculator. Take 3 divided by 8, get the decimal. Take 1 minus that, and you'll get a decimal value. Okay. You can always,
Minus 2/8, no?
no, minus 5.
3.375.
So you get 8 minus 3.
Went straight across, you subtract the top, but you carry the bottom.
Yes.
So the bottom stays the same, but you subtract
So
the.
it's 8 minus 3 all over 8. Okay.
You could just convert it into a decimal, so 3/8 would be 0.375. So 1 minus 0.375 will be 0.625, which is 5/8.
Yes. And depending upon your there's calculators that will convert between fractions and decimals for you. And again, all you have to do is take 3 divided by 8 on a calculator. I think you're right on. 3 divided by 8 is 0.375. So then you take 1 minus 0.375, you get 0.625. If you take 5 divided by 8, watch, you'll also get 0.625. So part of doing math is, again, you don't have to love fractions, but realize there's ways we can find to work around them. And using a calculator fractions are just a division problem. But yes, there's all these rules of how we multiply them, how we subtract them. And what I try to do is get you far enough in the mathematics you see the use for them, and then you may want to take the time to get those technical skills. The typical way they do is like in MAT091. How many of you took MAT081? Or arithmetic? You probably spent a whole unit on doing these, but you did so many problems and you didn't necessarily see where they would be valuable. You didn't say how you were going to apply it. So maybe you weren't all that motivated to do it. But so as we move on, we'll get motivated. These are techniques that are typically taught beforehand, and they don't teach them again. Typically, what you'll start seeing is college professors will just assume that you know how to do this, and they'll say, blah, 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 there it is. Okay. I try to take it through the steps because I realize this is still one of the struggling parts. But if you have difficulties working with fractions, again, find a technique. Whether that's working sort of the hardcore way, getting common denominators, or whether that's finding the way to use the calculator to turn them to decimals and work with them that way. John Dewey says use the decimals. Yes?
So, I'm sorry. So is the answer then y equals -1/8 plus 5/8?
You got it. So yeah, I got distracted. I never got to the final answer. The slope is -1/8 x plus 5/8, yes. And again, that's going to be a difficult one to graph because 5/8, you know, if you have a graph that goes by ones, that's an estimated. It's somewhere between 0 and 1. So you're estimating. And you're rising 1 and running 8, or you're rising -1 and running 8 or something. So they're not necessarily easy to graph. But if you take more math as you go on, we have graphing calculators that will actually do the graphing for you, and you'll see how that works. If you take 141, we're not going to get more into graphs. We're not going to, it's more of a mathematics of life. If you go to 121, you'll be dealing with a graphing calculator that will handle these for you. And then we do a lot of mathematics graphically. We work with the decimals more than the fractions because that's what the calculators handle best. Okay. So we've got all these tools, but just, you know, find your area. But don't let if you're not real good with fractions, there's multiple ways to get around it. Okay, so get the main thing. So how is that? Okay, parallel, same slopes, perpendicular, inverse negative slope, opposite slope. If one's negative, the other one's positive. If one's positive, the other one's negative. And you always flip it. That's perpendicular. Okay. And that's why I kind of wanted, it ties in everything we did. Once you have the slope, you write the slope, plug in the point, and then do the math. Okay, we were doing this last Wednesday as well, so it's kind of a good review of what we were doing last week. This throws in two different things of when they tell us parallel, then they're telling us we have the same slope. When they tell us perpendicular, we have the opposite reverse slope. Okay?
Well, do you have any of what is in 10.4 of the word problems? Will we have those in
On the test?
The test?
Sure.
Okay, so you will go over them then, or no?
Who cares about it? Of course we'll go over it. But what I'd like you to do is spend the time, in fact, we'll take a look at maybe just one of them, and I'll show you how they are word problems, but they're really not anything different than what we've been doing here. Okay, so let's take a look. Let's go here.
But it's gonna be problems.
So there'll be a few. Remember, we have a practice test, and we've got a whole week.
To prepare.
So we had the practice actually for this last time.
Yeah. We'll go over it. Okay. So, and this one's on the video. Maybe I should do the you try, the one that doesn't, because this one you could watch them work on the video. So let me do the you try, since there's no video on it. You try. Here we go. A tree is 3 feet tall. So I see a number and it's 3 feet tall. When it is planted, and it grows by approximately half a foot each year. Half a foot each year. Let h of t represent the height of the tree in feet after t years. The following determine a linear equation to represent the given situation. Use the indicated variables in proper function notation. Well, they give us, I mean, we could think of this as y equals mx plus b, right? So the output, again, with function notation is going to be, instead of y, they'll put h of t. And so if t is the input, instead of using x, they'll use t. But what have they given us here in these two pieces of information?
Well, it's 3 feet tall and it grows approximately half a foot each year.
So what does that tell us about the linear equation? Which one of those is the slope and which one of those is the starting value?
Slope is a half.
Good, that's per year, right?
Per
Each
year.
year it's going to get half foot and a half foot and a half foot. That's the growth rate. So this here is the slope. So when you find a rate each year, per year, something like that, that's going to be your slope. So a half foot, you could do it as 0.5 if you want, or 1/2, however you want to do it. But then do we have any indication of how tall it was when it started? When it wasn't 3 feet. It was that tall when it was planted in its new location. Obviously it was growing someplace else. Trees don't just start at 3 feet tall. They start as a seed and then they become that. But this one was planted in at 3 feet. So, now the equation comes for the homeowner. That's it. So this is what they're looking for. They gave you the slope and they gave you the vertical intercept. You just need to put them both in their place. Okay. So again, these are your word problems. It's taking some problem solving to figure this out, but they will always give you either the slope and the starting value, the slope and a point, or they will give you 2 points. Okay. So as you work through these, that's all the word problems are doing. And then you come up with the equation of the line. Okay. So they're going to be easier to take a look at once you've practiced the previous problems before this, where they say, here's 2 points, give me the equation of the line.
So they don't want an answer, they're looking for the equation that you would use in order to solve the problem?
Yeah. Because they haven't told us, there was no question that after 5 years, how tall is a tree or something like
Okay.
that.
Okay.
They just want the equation. For each of
And
the
it will be-
determine a linear equation. That's what they're asking. It's kind of like, it doesn't feel like they even asked a question, does it?
Which will be H T, I mean,
Yeah, H
the height of time, which is half time plus t.
Yeah. And t is in years, as they said. And h of t is in feet. So Input is in years, output is in feet. And then they can ask all sorts of questions like when will it be 50 feet tall? You plug in that and you solve for how many years that takes. Maybe it'll never be 50 feet, right? Not all trees get to be 50 feet, but if it were to grow at the set rate. Okay. So that's what the application problems are about. But you'll find if you get practice with the previous stuff, where they just give you points, slope, and do those problems. Given the slope and a point, find the equation. Given 2 points, find the equation of the line. Practice those, and then when you come back to here, I can show you how they're just the same thing, but you've got to pick the information out of the paragraph. But I say you'll be fine if you skip this section. You'll still get a passing grade, and you'll find that if you skip this for now until you do kind of master the other stuff.
Which is chapter 10, unit 10 or not?
This is unit 10.
Okay, but the one you want to master is the
Well, 9 and 10. 9 we did slope, so if you go back to that. 10 we're doing slope and Y-intercept. That's really what I got added in. So we still need to be able to get slope, but now in 10 we just added the vertical intercept. When we get to 11, which we'll do on Wednesday, what we have is we have 10 and 9 kind of thrown together. We're going to look at it. Well, you want a little preview? I can do it in, say, 3 minutes. Or do you want to wait till Wednesday? It's up to you. Okay. 11, not sure. Not sure if you can handle it, right? Okay, we can handle it. Won't be too much work. So, okay. So 11, all they do in 11. What 11 will do? They'll start with an equation like this, and you'll need to get it into slope-intercept form. Okay, so this doesn't look like what we've been working for, does it? We've been working with y equals mx plus b. So they're going to give us this, but could we get this into y equals mx plus b? Sure, we've got the skills. So we'll subtract 3x from both sides, right? We've done this before.
We can flip it. We can put 12 this side and...
Sure, you could do that. Yeah, equations you could do any way you want to do it. So you can, just rewrite it as 12 equals 3x plus 2y. But the goal is going to be to get y by itself because that's how this thing is set up with y by itself. Okay, so in 11, I'm just trying to show you it's really kind of the same thing we did in 10, except we start off with a little bit of a mess. We'll subtract the x from both sides, so that gets rid of it from here. We could write this as 12 minus 3x now equals 2y. We still want to get y by itself, so what would we do? Get rid of the 2, how?
Divide?
Exactly. So we'll divide this by 2, so we have to divide the other side by 2. The whole other side. And this might bring back memories. So this cancels. We get y equals, and then you have to distribute this 2 to both of these. 12 divided by 2 is 6. 3 divided by 2 is 3 halves. And notice we now have an equation y equals mx plus b. If you want, you could reorganize it with y. You could put the x part in front, 3 halves x plus 6. Another way to write it. But that's what we're doing in 11, is we're just reorganizing linear equations. Okay. We'll do some of the word problems there because you'll see what we'll do. is that this is a useful way to set up several types of
We
problems.
saw that before, but it's like,
Yeah, I know. But see, this
it was.
if you got it, then you don't even have to come back on Wednesday, right? Because this is what Wednesday's going to be in a nutshell. We will take the time to go through it. Yeah. Well, it's because you got the variable. But that's what. So what we're doing is we're still working with y equals mx plus b, but they opened the box and they didn't put it back in the box right. Everything's in the wrong order, so we're putting it in the right order. That's all we're doing.
It's about math, but something fun.
Perfect. Okay? So that's 11, a little preview. We'll be fine. And then what we do next. So, but take the time to go through before then. Go through most of 10. Don't go through the applications just yet. They're not a big deal. We have plenty of time afterwards. But get down how to find slope. Get down for TI-83. Please bring it with you. We can use it. That's not a graphing one. That's a scientific one. So that won't specifically help you. But so I'm going to show you one method that if you have a graphing calculator, you plug it in, you graph it, you get your answer. Okay? I'll show you two other techniques that don't need a graphing calculator, and you will get the same answer. And so you choose which method you want to use. Okay? And I'll have a worksheet for you. And then Wednesday will be time to practice. And I have someone lined up next Wednesday. I will be here this Wednesday, but the following Wednesday I won't be here.
That's not the test day.
No, it's not. Test is not until the final exam. Final exam is the 9 through 12. And that's, anyone know when it is? I think it's Monday, 7th.
Right?
Yeah,
It's Monday?
it's on the syllabus.
No,
Not,
this Monday.
yeah, it's May 7th,
May 7th.
3 weeks away. And it's not a comprehensive exam, it's just 9, 10, 11, and 12. Okay. We'll have a practice test before that, so we'll be fine. Okay. So we'll be fine. Okay. A TI-84 or 83?